we are looking at special angles today. So there are a few special angles. They're called special angles because their trig ratios are exact values. And these are special angles that you're going to need to remember this year and then next year in Math 30, Math 31, etc. So we're starting now so that by the time you get to Math 30, when it's super duper important, you'll have a really good handle on them. So let's look at a 45, 45, 90 triangle. So it's a 90-degree triangle. And so if the other two angles are 45, we know it's an isosceles triangle. So we're just going to let each of the equal sides be equal to 1 unit. So now it says determine the exact value of the length of the hypotenuse. So let's just call this x. And so it's Pythagorean theorem, right? X squared equals 1 squared plus 1 squared. So 1 plus 1 is 2. And so x will be it could be the plus or minus root of 2, but it's a side of a triangle. So we're going to take the positive root. So that's equal to root 2. Okay, so that's always going to be the case. If you've got a 90-degree triangle, and if you know one of the legs is 1 unit, and it's isosceles, then this will always be root 2. Okay, if it's isosceles, these have to be 45 degrees. So it says use the dimensions of the triangle to state the exact values of each of the following trig ratios. So sine of 45, remember, is opposite over hypotenuse. So that's 1 over root 2. We do need to rationalize that. So we're going to multiply by root 2, top and bottom. Okay, and so that gives us root 2 over 2. So sine of 45 is root 2 over 2. Well, what's cosine of 45? So that's adjacent over hypotenuse. And so that would be same thing, 1 over root 2, which is root 2 over 2. Okay, and then tan of 45 is opposite over adjacent, 1 over 1, which equals 1. That's always going to be the case. If we wanted to check with your calculator, so if you get out your calculator and your calculator, graphing calculator, TIs won't give you the exact value of the trig ratios in radical form. If it does, then it's a calculator that's actually not allowed. And so in any case, it will give you the decimal form. So if you check your calculator, make sure it's in degree mode, then go sine of 45, enter on that, you get a decimal. Let's check what we think it is square root of 2, cursor out, divide by 2, we get the same decimal. Okay, so we know we've done it correctly. That's always going to be the case. So we'll always reduce to this, even if you multiply both sides by 2 or by 3. Here, the ratio, all the sides are proportional, so this would be multiplied by 2 or 3, depending on what you're multiplying by. Okay, so that's the 45, 45, 90 triangle. So we consider 45 as a special angle. Next, we're going to look at 30, 60, 90 triangle. So we've got a 90-degree angle, and then we're saying that one of the acute angles is 30, one is 60. So determine the exact values of x and y. So we actually have to find the leg and the hypotenuse. In order to do this, we're going to look at the diagram at the right here, where we actually have an isosceles triangle. If we take a look here, 30 and 30 is 60. Sorry, not isosceles, equilateral. So that's 60 there, 60 here, 60 here. So equilateral triangles have all the same angles and all the same sides. So in total, this side is 2. So if this is equilateral, that means that x is 2. Okay, and so in order to get y, we look just within that 90-degree triangle, and we use Pythagorean theorem for that. So now y squared is the hypotenuse squared minus one of the legs squared, because we're just looking in that triangle. So here we know it's 2, and so now we're figuring out what y is. So 2 squared is 4, minus 1 is 3. Y equals plus or minus the root of 3, but again, it's a length of a side, so we're going to take the positive root. Okay, so this is root 3. So when we find our trig ratios here, sine of 30 is opposite over hypotenuse, so 1/2. It's already reduced. Cosine of 30 is root 3 over 2. Okay, we don't have to do anything to that. Tan of 30 is opposite over adjacent, so 1 over root 3, and so we have to rationalize that. Okay, so we'll multiply by root 3, top and bottom, and that's going to be root 3 over 3. All right, so again, 30 degrees is a special angle because we can find the exact value of the ratio. Then looking at 60 degrees here, the sine ratio will be opposite over hypotenuse, so that's going to be root 3 over 2. Cosine will be adjacent over hypotenuse, 1/2. And tan will be opposite over adjacent, root 3 over 1, which is root 3. Okay, and remember we've talked about this before. Sine of an angle is equal to cosine of the angle that adds to 90. So 30 plus 60 is 90, so that means these are both going to be a half. These are both going to be the same. Okay, so those are the same. Tan of angles that add to 90 are reciprocals. Okay, so those are just some properties. Again, if we were to take this and multiply this side by 2, then all the sides would be multiplied by 2. It would still reduce to these same ratios. Okay, so we're going to have to basically memorize what these sides of the triangles are. We're going to fill them in the chart here. What you might want to, so what I do when I think about these, maybe draw a couple of triangles. Let's see if I can, here. So this actually gives me a 45, 45, 90 triangle. Okay, it's a 90 triangle. I can move that a little bit. There we go. So when I'm thinking about the sides of a 45, 45, 90 triangle, I think of the numbers 1, 1, 2. So I'm putting them in order. I know 2 have to be the same, 1, 1, and then the last one is square rooted. Root 2 is about 1.4 as a decimal, and so it's bigger than 1. Then if in my 30, 60, 90, okay, so something like this, close enough. Then when I'm thinking about the sides in this, the digits are 1, 2, and 3. Okay, so that was 1, 1, 2. Square rooted. This is 1, 2, 3, and the last one is square rooted. So then think about what value. So this is about 1.7 something, and so 2 is your longest side, your hypotenuse. 1 is your shortest side, and root 3 is the medium side. Okay, in terms of the sides, the smallest side is opposite the smallest angle. The biggest side is opposite the biggest angle, 90, and then the medium one, the middle one, is opposite 60, which is in between. Okay, so when you're thinking about sine of 30, it's going to be opposite. So 30 is the smallest angle, so the opposite's going to be the smallest, 1 over 2. Cosine is the medium one, root 3 over 2. And tan is 1 over root 3. And just remember that when you rationalize that, that's root 3 over 3. Okay. Then 45, so this is 45 and this is 45. So sine is opposite over hypotenuse, 1 over root 2, but remember, rationalize, that's root 2 over 2. So you can just remember it that way. Okay. Or what you can do is, I'm going to get this to be red here. What about if, you know, when I said you could multiply each side by the same number, what if I divided this side by root 2 so that I got a hypotenuse of 1? Then that means I have to divide both sides by root 2, okay, to keep them proportional. And so that's equal to root 2 over 2. So is this. Okay, so now when I take the cosine, it's adjacent over hypotenuse. Root 2 over 2 divided by 1. Whenever you divide by 1, it stays as itself. So that's going to be root 2 over 2. So rather than dividing, so this is root 2 over 2. That's more of what you're going to do in Math 30 because we're always going to take a hypotenuse of 1. In terms of tangent, that is always going to be 1, right? Because the sides are equal. Then let's look at doing it this way for the last row here. So again, if I decided to make that hypotenuse a value of 1, I'd have to divide each side by 2. Okay, well then in this one it's pretty obvious. You don't even have to rationalize anything. Your sine of 60 will be root 3 over 2 divided by 1, which is root 3 over 2. Cosine will be 1/2 over 1, which is 1/2. And opposite over adjacent, that's just going to be root 3. Okay, so again, notice that this one's the same as this. This one's the same as this because they add to 90. These are the same as well because 45 plus 45 is 90. Okay, and these two here are actually reciprocals. Okay, 1 over root 3 is root 3 over 1. All right. Okay, so now it says determine the exact value of each indicated side. So this is going back to what we did in the second day, I think, of trig, but we're not going to give decimal answers. So we're determining each side. We could actually find the angle, right? That's 60 degrees. So really we're solving the triangle in that sense. So if we take a look at this, we know that sine of 30 degrees is opposite, which is y, over 12. Okay, and we want to find y. So y equals 12 sine 30. What we did on day 2 was plug that into our calculator. What we're going to do today is replace sine 30 with the exact value. So again, if you want to think about it, I think about the 30 being down here. Doesn't matter actually where, but then my shortest side is here, longest, medium. So sine of 30 is opposite over hypotenuse, which is 1/2. So actually, if you did use your calculator, you would get this whole number value, so you'd be okay. But for cosine, you're not going to get that. So now cosine of 30 degrees is x over 12. So x is 12 cosine 30 degrees. So now when we think about 30 degrees here, that's adjacent over hypotenuse. That's 12 times root 3 over 2. And then reduce that. 2 goes into 12 6 times. Okay, so then you get 6 root 3. Now you can check it with your calculator, but your calculator can't convert to radicals. So what you can do is go, okay, I'm going to put in 12 cos 30. It'll give me a decimal form, and then now enter 6 root 3 and make sure you get the same value. So you're good. Okay, didn't have units, so we'll just leave it without units. Next one, 45, 45, 90. So we can put 45 there. And we're just asked to get x because really x is the same there. We know the hypotenuse. So x compared to 45, I'm going to use cosine. So cosine 45 is adjacent over hypotenuse. So x equals 20 cos of 45. And then think about in just our special triangles, when this was 45 and this was 1, this was 1, and this was root 2. So now when we do cos of 45, it's going to be 1 over, so cos of 45 is 1 over root 2 or root 2 over 2. I'm going to put the rationalized version because otherwise I'm going to have to rationalize at the end anyway. So now that goes in once into this 10 times, and so my answer is 10 root 2. All right, so always think back, what's the exact value of cos of 45? Okay. So another one here, another 45, so this is 45. In any case, now we want to find x and y. So in this one, I'm going to use tan to get x because we know the adjacent. So tan of 45 is x over 8. So x equals 8 tan 45. All right, I still have my 45 triangle up here actually. So this is 8 times, what's tan of 45? Well, 1 over 1 is 1. So x is actually 8. Oh, actually, I didn't even need to do that because if this is a 45, 45, 90, this is equilateral. Sorry, we did an extra step, but it just confirms it, right? And then now, really, do you need to use trig? Not necessarily. Let's do it both ways. Let's use trig and then the Pythagorean theorem. So for y, I don't know, you decide. Let's use cosine. So cosine of 45 equals 8 over y. So remember, when your unknown is in the denominator, you divide by your cosine, 45. Okay, so now it's going to be 8 over. Now in this case, I'd actually maybe choose 1 over root 2 because when I invert and multiply, then I don't have to rationalize. That's going to be 8 times root 2 over 1, which is 8 root 2. Okay, now if you didn't use that, you could have used Pythagorean theorem. Y squared equals 8 squared plus 8 squared. So that's 64 plus 64, which is 128. So y equals, we know it's going to be positive root because it's the hypotenuse there. So root of 128, you can leave the plus or minus off. And that 128 is 64 times 2. So that's going to be 8 root 2. So you could get it both ways. Okay, next one's a big triangle split into two parts. We know this is 15. So this is, again, just like we did those two triangle problems, except we need to give exact values. So in order to get x, we need to know something more in this side, in this triangle here, right? It's 90, it's a 45, 45, 90. So if we could get this shared side, so I'm going to call that y, then we can figure out what x is. So we could use sine law or cosine law if we had, again, more information, this whole side or something like that, but not enough. So compared to 30 degrees, that's opposite, and this is 15 is adjacent, so I'm going to use tan. So tan of 30 degrees equals y over 15. So y equals 15 tan of 30 degrees. Well, what's tan of 30 degrees? So again, I'll just draw it rather than going back. So if this is 30, in your base triangle, that was 1. This is 2, this is root 3. Okay, and so tan is 1 over root 3, which remember is going to be root 3 over 3. So I'm going to replace this with root 3 over 3. And then 3 goes into 15 5 times, so that's 5 root 3. So this is going to be 5 root 3. Now, to get x, again, you could say, well, you know that this would be 5 root 3. So you could use Pythagorean theorem. Or you could use, how about sine? So sine of 45 is opposite over hypotenuse. So again, you're dividing. So that's 5 root 3 divide by sine of 45. And then in your 45, 45, 90 triangle, so 1, 1 root 2. Sine of 45 is 1 over root 2. Okay, so we can go, I'm going to use the 1 over root 2 rather than the rationalized because it's in the divisor. So this will be 5 root 3 times root 2 over 1. And remember your multiplication of radicals. That's going to be 5 root 6. All right. Now, do you want to check using Pythagorean theorem? So that would be x squared equals 5 root 3 squared plus 5 root 3 squared. Well, 5 root 3 squared is 25 times 3, right? Root of 9 is 3, plus 25 times 3. They're exactly the same. So that's 75 plus 75 is 150. Then we take the positive root of that. Okay, and that's going to be 25 times 6, right? And so that's going to be 5 root 6. Okay, and the last one, a rear window wiper blade is 48 centimeters long. A blade moves between an angle of 30 degrees and 135 to determine the exact value of the horizontal distance that the tip of the blade moves. So basically you have like your back window, a lot of back windows, you know, it's going to be something like that, right? And so your blade, let's do it in red here. Okay, so it's from there, it's going to start at the 30 degrees and then go like this. So when we draw our, we want the horizontal distance. So basically we want the distance. So when we drop those down to the horizontal, this is what we want to figure out. Okay, so this was 30 degrees. And then what it means is, between an angle of 30 and 135. Okay, so not 135 from there. So this is 135. Okay, so if we've got this here, we know that the blade is 48, so we can figure out, I'm going to call this part x here and this part y. We do need to know this angle in here. So think about 180 minus 135. We've talked about angles in standard position, right? So really what we're trying to find is the reference angle here. So that's 45. Okay, so in calculating this, we're going to need to use, that's adjacent over hypotenuse, so cosine of 30 degrees is x over 48. So x equals 48 cos 30 degrees. And so 48 cos of 30, remember in your 30, your base triangle, this is 1, 2, and this is root 3 for 30 degrees. So that's root 3 over 2. So that's 24 root 3. And then we need here in this triangle, this side here, it's a distance, so it's not a location on the coordinate grid. It's cosine again, because this is 48 here. So cosine of 45 is y over 48. So y equals 48 cosine of 45. And then remember, for cosine of 45, that's root 2 over 2. So that's 24 root 2. So therefore, the horizontal distance equals 24 root 3 plus 24 root 2. Okay? And that is, what does it say? It's probably centimeters, right? Centimeters. Now you could, they're both 24s. You can't add them together so they're not like terms. You might see, maybe you might show it as 24 times root 3 plus root 2. But I wouldn't, because it doesn't say to factor it. Okay? And that's it.